In last videos, we discussed about how to test the hypothesis regarding the population mean, population proportion, and population standard deviation or variance, right? And also we did the confidence interval for population mean, population proportion, and population variance as well. But we have not talked about the relationship between two variables. For example, let's say height and weight. Suppose you have the data for heights of the people, height of the sample of people, and weight. So what can we say about the height and weight? So are they related to each other? If you increase the height, or if the height increases, does the weight increase or decrease? Those kind of relationship we have not studied so far. Okay, so in this chapter we will be talking about what are the relationship between the two variables and how do we find out that, and how do we test the hypothesis about the population from the sample data. Okay, so the method to test or to find out the relationship, or actually the linear relationship between the two variables, is called correlation. Okay, actually we can find the relationship between more than two variables, but in this book, in this course, we will be basically focusing on linear relationship between two variables. Okay, so correlation is a statistical method used to determine whether a linear relationship between variables exists. So in this chapter, we try to answer the questions such as, are two variables related? If yes, what is the strength of the relationship? And what type of relationship exists? Meaning, whenever you increase one, does the other increases or decreases? So the type is maybe positive or negative relationship, okay? And what kind of prediction can be made from the relationship? The first section is 10.1. So actually we skipped chapter 9, okay? This is not in the course. So chapter 9 will be seen in the next statistics course. So for chapter 10.1 is the correlation. Okay, so correlation is a study that contains two variables. Correlation measures the relationship between two variables and their strength. In this case, one variable is called independent variable and the other variable is called dependent variable. Now how do we know, how do we determine which one is dependent, which one is independent? Okay, let us consider one example. Consider example, so two variables example, that is grade received and the number of hours studies. So which one depend on what? Is the grade received depend on number of hours studies, or number of hours study is depending on the grade received? Definitely the grade received, whatever you the grade you get depends on how much you practice, how many hours you spend in the study, right, and reading the material. So this is the dependent variable because the grade depends on the number of hours studied. So this is the dependent variable and this is the independent variable. So independent variable is x and dependent variable is y in this example, where y is denoted for we denoted grade received by y, and then we denoted the number of hours studied by x. Let us see, for a study with more than two variables, correlation measures how the variables are related. In this case, there are more than two independent variables. Okay, for example, consider the area G and length x and width y, right? So the area actually depends on length and width. If you increase the length, or if you increase or decrease the width, if you change the value of length or width, then the value of area will changes, right? So the independent variable are x and y, right? And the dependent variable is g here. So there can be more than one independent variable, okay? But there is only one dependent variable. All right. So the scatter plot, we have seen the scatter plot in chapter 2. What we do is, it is a graph of the order pairs x and y of numbers consisting of independent variable x and the dependent variable y. Basically what we do in the scatter plot is you draw x and y, right? X and y, and then you plot. So the different values of x, and then this is one order pair, this is another order pair. Plot the order pair like x and y. The data will be given like this, a number, let's say 57, okay, and then say 51, 9, let's say 53, 18, and so on. Okay, and what you do is you plug in 50 and then 7. So let's say this is like this is 0, let's say this is 50, 51, 52, 53, 54, like that. 50 and then 7. Suppose this is 1 point. And 51, 9. That is another point. 53, 52 is nothing. 53 is 18, right? And there may be another 53 as well. So that is possible, right? So in that way you will plot all those values of the order pair x and y, and this is called the scatter plot. Let's see some of the examples there. We will do the scatter plot of some of the examples, but before that, in section 2.4, we introduce scatter plot to see the relationship between two variables. Look at this, positive linear relationship. What does that mean? That means if you increase the value of x, if the values of y are increasing, meaning the height are increasing, right? For each increased value of x, then it is called positive linear relationship. Negative is whenever you increase the value of x, whenever you pick different values of x, the values of y are decreasing, meaning the heights are decreasing. Then you will see this type of relationship. So this one is no linear because it is a curve-like thing, because it is not increasing everywhere or decreasing everywhere. Whenever it is increasing everywhere, then it is called positive. It is negative, but it is increasing and decreasing mix. So it is basically like a curve, right? So we say it is non-linear or curvilinear. Okay, curvilinear relationship. And here it is not following any rule, because whenever you increase the x, sometimes the y value are increasing, sometimes the y value are decreasing. So basically there is no specific trend here. Okay, so it is no linear relationship. In a scatter plot of two variables, we plot independent variable along x-axis and the dependent variable along the y-axis. Okay, so what you do, the number of murders and robberies per 100,000 population for a random selection of states is given. Draw a scatter plot. Okay, is there a linear relationship between the variables? So how we do it is basically what is the smallest value. So which one is dependent and which one is independent variable? For the correlation, it does not matter whatever dependent you pick, whatever independent you pick. But for the regression, that is the section 10.2, it matters. Okay, first let's say this is murder is x and robbery is y. Okay, so what we do here is draw the values of x and y. So what is the smallest value of the x? Is 2.1, right? So let's start that. This is 2, this is 3, this is 4, this is 5, this is 6, this is 7. I think the biggest value is 6.6. So if you write up to 7, then you are good. What is the smallest value of y? The smallest value of y is 14.3 and biggest value of y is 173. What I want to do here is, let's say 50, 100, 150 and then 200. I want to write like that. So 50, 100, 150 and then 200. Okay, now so the first one is 2.4, 25.3. So 2.4 is somewhere here, right? And 25.3 maybe somewhere here. So this is 1 point. Next is 2.7, 14.3. So 2.7 is somewhere here, right? And 14.3 maybe somewhere here. Okay, 5.6, 151.6. 5.6 maybe somewhere here. 151 maybe somewhere. 150 is here, so 151 maybe somewhere here, right? And 2.6, 91.1. 2.6 maybe somewhere here, and then 91.1 maybe somewhere here. Okay, and 2.1, 80. 2.1 is here, 80 maybe somewhere here, and 3.3, 49. 3.3 maybe somewhere here, and 49 maybe somewhere here. Okay, 6.6. So 6.6 maybe somewhere here, and then at that time 173 maybe somewhere here. Okay, and 5.7, 95.8. 5.7 maybe here, 95.8 maybe somewhere here. You see that? So if you look at that, it sounds like a positive linear relationship, because if you draw a line through the middle of those data points, this is what you see, right? So it sounds like this is the positive linear relationship. Okay, if you draw a line from the middle of the data, this is what it looks like. Okay, so this is called the scatter plot. So basically you plot the independent variable along x-axis and dependent variable along y-axis. But in case of the correlation, it does not matter which one you put along x-axis, which one you put along y-axis. Okay, so you can see the trend, whether it is increasing or decreasing trend. Now, so this is the graphical way of checking the relationship between the two variables. But is there a mathematical or statistical way? Yes, there is. So how do we decide that? So this is called the correlation coefficient, and we denote by R. This is for the sample correlation coefficient. So if you want to do for the population correlation coefficient, that will be denoted by rho for the population. We call rho, R-H-O for the population, and for the sample, this is the correlation coefficient denoted by R. This is the formula for R. Okay, so to measure the strength of linear relationship, we evaluate correlation coefficient R given by N is the number of order pairs. Okay, so number of order pairs. For example, in the above example, so N is like, this is like 1, 2, 3, 4. This is how you count N. Okay, so N is the number of order pairs, and then X is one variable, Y is another variable. So it is like X times Y. You will do X times Y there, and then minus sum of the X, sum of Y, divided by N is the number of order pairs, times summation X squared. We will do an example and you will see how to use this formula. Okay, minus summation X whole squared, and under the root times, there is a times in the middle, and then N times summation Y squared minus summation Y squared. Okay, so first of all, let us see how do we interpret the result. Okay, so interpretation of the sample correlation coefficient R is, if R is close to 1 or negative 1, if R is close to 1 or negative 1, then the relation is strong. Meaning, it will be, if it is close to positive 1, we call positive correlation. If it is close to negative 1, it is negative correlation. If it is close to 0, then there is no correlation, or the relationship is weak. Okay, if R equals to 0, there is no relation. From the formula, we evaluate the correlation coefficient. We need columns of X and Y will be given to you, and then you find out X times Y, X squared, and Y squared. That's what you will find out. Okay, so look at that interpretation of R value. If R is close to 0, then we say no linear relationship. If R is close to negative 1, we say negative linear relationship. If R is close to positive 1, then it is called positive linear relationship. See, this is positive, close to positive, right? This is 0.5. See, close to positive 1. So this is 0.9. It is even better, even close. See, if it is positive, you see the increasing trend, increasing pattern. But if the dots are very close to a line, then you see that it is strong. If the dot is perfectly on a line, it is perfect positive linear relationship. You see that R equals to 1. Similarly, this is weak linear or weak negative linear, right? It is strong negative linear, and it is perfectly negative linear. Okay, all right, this is how we interpret. Let us see one example how to do by hand. So again, we can do it by using calculator. I will show you how to do that. Okay, let us see example number 3. Compute the value of linear correlation coefficient for which the data obtained in the study of number of absences and the final grade. Okay, so X denote the number of absences and Y denote the number of the total final grade a particular student got. For example, a student missed 6 classes, his final grade was 82. Another student missed 2 classes, his final grade was 86. Another student missed 15 class, the final grade is 43, and so on. This is what it is given. Okay, student, these are the student 1, student 2, like that. Okay, so sample of 7 students were picked, and then the number of absences and their final grade was recorded like this. So we want to know, is there a linear relationship between number of absences and the final grade? Meaning, does the final grade depend on the number of absences? And when we think it sounds like yes, right? Because if the number of absences increase, the final grade is decreasing, right? Whenever it is 15, the final grade is 43. 12, 58, right? And for the lower number of absences, it is like bigger number. You see that? Okay, now we want to find out the correlation coefficient R by using this formula. So what do we need? We need X times Y, the column of X times Y, right? And also we need the column of so X squared. See, we need the column of X squared, we need the column of Y squared. For the summation X, summation Y, you just add them and then find the summation X. Add them, summation Y. It should be uppercase, because this is uppercase X and uppercase Y, right? All right, so we need X times Y. So what we do is we multiply 6 and 82. So how much is 6 times 82? So 6 times 82, if you do that, you will get 492. 492. If you do 82 times 86 times 2, you will get 172. The sum of these is 57. Sum of the y is 511. Sum of this, if you use calculator, the sum will get 3754. 3754 will be the summation of x times y. X times y. Okay. So 6 square is 36. 2 square is 4, right? 15 square is 225. Another one is 81. Another one is 144. Another one is 25. And another one is 64. If you find out the sum of the x square, you will get 579. This is the sum of x square. Okay. Similarly, let's find out y square. So y square is square of 82, square of 86, and so on. So if you do that, you will get 6724. These are the square of these. 82 square, 86 square, 43 square, and so on. If you find out the sum of y square is 38993. Okay. Now we will plot this. So how many pairs? So n is, so 1 pair, 2 pair, 3, 4, 5, 6, 7 pairs, right? So n equals to 7. That's what we do. Now what we do here is, we don't need the first column because these are just the student name. Okay. So we didn't use that. So this is n equals to 7. That's what we use. That's what we got here. Okay. So let's plug in the values. 7 times summation x times y is 3754 minus summation x is 57 times summation y is 511. Divide by under the root 7 times x square is 579 minus, so summation x square, summation x is 57 square. That's what you get, times another root. We get 7 times summation y square is 38993. Okay, this is summation y square minus summation y square. Summation y is 511, and then square that. So everything is under the root. So if you use calculator for this, so basically what you get, this is not 7 point, this is 7 times. Okay, so if you use calculator, you will get negative 0.9423. So negative 0.9423. So note that these values of r will be always less than 1 and greater than negative 1 or equals to those values. Okay. So the next thing I want to do is, how do I do this problem and find out r directly using the calculator? Okay. That's the next thing that we want to do here. What we do here first is go to the stat and then hit enter. Now what I want to do is, I want to enter the values of x and y here. Okay guys, so let me clear what I have here. Okay, so what are the x values? So x values are 6 and then enter, and then 2 and then enter, and then 15. So I enter all the data. What you do next is go to the stat, okay, and then go to calc, okay, and then see linear regression. Linear regression, that's what you do. So go to the number 4, okay, and if you hit enter on the number 4, so where is your x list? X list is are in L1. Okay, so what you do is second one takes L1 there, and y list are in L2. Frequency list, you don't have to enter anything. Store regression, so go to the you don't need to do anything for the frequency list and store regression, and then you hit calculate. So this is what you get. So r value is missing. Okay, so here r value is missing. So this is giving you y, a and b only, but r value is missing. So how do I get that r value? So you need to turn on the diagnostic first. So how do I do the diagnostic turn on? Is go to the second and then catalog. Go to the second and catalog. I'm sorry, it is not working that way. So do the second and then catalog. It will give you all the catalog values. So scroll down by clicking the downward button. Scroll down, and then you will see diagnostic. Okay, so diagnostic. Did I pass that already? So let's see. Look at that, diagnostic off and diagnostic on. So you need to pick diagnostic on and hit enter. Okay, and hit enter again. So diagnostic on is done. So it will show you the r value, the correlation coefficient value. Now do the same thing, second, and then go to calc, and then go to the number 4, okay, number 4, and then just hit enter, keep pressing enter. If you do that, you will get the value is negative 0.9442. so this is what you get, negative 9442. so this is very close, right? So negative 0.9442. Now what is the meaning of that? So how do you interpret this value? Is, see, what was the R value? Was negative 0.9423 or 9442. So you got 9442 from calculator, and we got 9423 from here. So it is just depending on how many decimal places we consider. Actually, usually we consider 2 decimal places, okay, but even if it is more decimal places, that is better, okay, if you take more decimal places. Now, so the reason why I got slightly different from this is whenever you take the square root and then pick the values of the square root, that depends on those values, okay guys? So how many decimal you pick when you do the square root of that values. All right, now it is close to -1, right? Close to -1 means it has a negative linear relationship. What does that mean? That means if you increase the value of x, y will decrease. And that makes sense, right? If number of absences increases, then the grade will decrease, right? If you decrease the number of absences, then the grade will increase. That's what it says, okay? It has a negative correlation. All right. So I have mentioned here, how do I do this using the calculator directly? So you need to turn on the diagnostic by doing second and then 0 and scroll. So for the diagnostic, as I mentioned already, second and then 0, right? Second 0 will turn on the diagnostic and scroll down, and then to diagnostic on, and then hit enter, okay? And enter the data in L1, and then L2 via stat and edit. Then press edit, calc, linear regression. There are 2 options there, okay? There is, one is AX plus B, the other is A plus BX. Look at that, stat and then evaluate, calc. The number 4 is AX plus B, and number 8 is A plus BX. You'll get the same R value either way, okay? But one has AX plus B, MX plus B form, another is B plus MX form, but either one is good, okay guys? So that's how you do using the calculator. Let us do one more example using the calculator, okay guys? So I want to enter this in my calculator and then find out R. Let us do that. So first of all, I want to read the question. So let me clear everything that I have. So the question says that an environmentalist wants to determine the relationship between the numbers in thousands of forest fires, number of forest fires in a year, and the number of thousands of acres burned, okay? So number of thousands in the forest fire and number of thousands in the acres burned. The data for 8 recent years are shown, okay? Describe the relationship. If there were 70,000 fires, then 62,000 acre land were burned. 69,000 fires, 42,000 acres land were burned, and so on. Now we want to find out, is there a relationship between those x and y variable, okay? Let us first go and then go ahead and then enter the data, okay? So that's what I want to do. Go to the stat and then hit enter. So I want to enter 72, enter 69, enter 58. So I finished entering the data in L1 and L2, right? And as in the previous example, go to stat and then calc and then go to number 4, y linear regression, that is AX plus B. So I enter in L1 and L2. Okay, calculate that. If you do that, you get R equals to 0.7705. So R equals to 0.7705. So this is also positive because the value of R is positive, right? And then it is close to 1. So it is like highly or strong positive linear relation, meaning if the number of fires increase, then the number of acres burned also increase. That is the interpretation of this, okay? So as I mentioned earlier, the population correlation coefficient is denoted by rho, and the sample correlation coefficient is denoted by R, okay? So next thing we want to do is we want to do the hypothesis testing for the population correlation coefficient, okay guys?